Today's lesson is on proving that a quadrilateral is a parallelogram. We have a few theorems about parallelograms and the properties and what makes a quadrilateral a parallelogram. The first one says if both pairs of opposite sides are congruent, then it is a parallelogram. Our next one says if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Our third one says if one pair of opposite sides are congruent and parallel, then it is a parallelogram. This is different from the original property of a parallelogram. Our next one says if diagonals bisect each other, then the quadrilateral is going to be a parallelogram. In our first example, we're determining if it's a parallelogram. So I'm going to sketch out a quadrilateral. We'll label it ABCD. It says AB is equal to BC and CD is congruent to AD. Is it a parallelogram? Parallelogram we know has opposite sides congruent. This one has consecutive sides congruent, so this is not a parallelogram. Remember that what has two pairs of sides equal on one piece and two sides on another could be something as simple as a kite. And a kite is not a parallelogram. In our next example, we're finding the values that make it a parallelogram. This would mean that the opposite sides are congruent. So the first thing we'll do is figure out what x equals by setting up 24 minus x equal to x plus 6 to find x. If we bring the x's to the left side, we have 24 minus 2x equals 6. I'll subtract 24 from both sides. We have negative 2x equals negative 18 divided by 2, or negative 2, which equals 9. So that would mean x equals 9, which means our side lengths are 15. If we plug x in for the top piece, 2 times 9 plus 3 is 18 plus 3, which equals 21, so y equals 21. In our next example, the question is how do we know that, or show how we know that angle S is congruent to angle U. If we look on the picture, we have opposite sides are marked, one pair are marked congruent and parallel. And then our reasoning for this, angle S is congruent to angle U. Those are opposite angles congruent. We already know it's a parallelogram, therefore the opposite angles have to be congruent, and we know it's a parallelogram based on our theorem about one pair of opposite sides are congruent and parallel. For what value of x is quadrilateral CDEF a parallelogram? We know diagonals bisect each other, which means that they are equal to each other. Set them equal to each other. We'll solve for x. I'll bring 2x to the right by subtracting it. 17 equals 14x minus 2x is 2x minus 11. I'll add 11 to the other side. So 28 equals 2x. Divide by 2. X equals 14. In our last example, we're showing that it's a parallelogram. Pick one of the properties, how you know it's a parallelogram. So I might do opposite sides are congruent, opposite sides are parallel. Angles we're not sure of on this, but we do know that we could find slope. Opposite sides are parallel, same slope, or distance. The opposite sides are the same or congruent in length. So I'm going to use for this one the slope, so opposite sides parallel. Which means they have the same slopes. So if we use the idea of slope is rise over run, we can find the slope of the sides. So for side, start with CD. Our slope would be down 2 and to the left 2. So negative 2 over negative 2 would be positive 1. On the other side, we're going up 2 and over 2. So 2 over 2 is a slope of 1. On the other side, we're going to the right and down or up and left, so rise over 1 is we're going up 2 units and to the left 4. Which equals a negative 1/2. And on our other side, we're going down 2 and to the right 4. So which also equals negative 1/2. So same slopes indicate that it's a parallelogram.